Let's take a look at today's lesson. Today we will be solving linear functions. We will be able to explain how to solve linear functions. So let's take a look at today's lesson. In today's Do Now, it says solve each equation below and write your answer using set notation. So I'm going to start off by asking you guys to pause this video and answer the Do Now question number 1 and number 2 on your own. And then when you finish, you play it back. So pause the video right now. Okay, so here are the answers that you should have got. For number 1, you should have gotten a value of x equals -8. I did not box up my answer because they asked me for set notation. So I want to make sure you guys write your answer using set notation. For number 2, the value was y is equal to -22/19 in its most simplest form. So when they asked me to write my answer using set notation is always written with curly brace. So you'll put the curly brace and only the number that you got for x. So in this case, -8. For number 2, my set notation, in curly brace, -22/19. So now that that is my answer, I'm just going to box them up. So let's keep going. Example number 1 says, solve each of the following and represent your answer using set notation. I have 1 pepper here, which means that this is not the hardest type of question. So again, I ask you to pause the video and try these 2 questions on your own, and let's just see if we end up at the same answer. Okay, so for number 1 in this example, you should have gotten a value of b is equal to -40/3. So I wrote my answer using set notation. If I'm walking through the process, we would have distributed first, got rid of all of those. Even though I have fractions, I could use my calculator, simplify, combine like terms, move things over. So it's the same thing as if we were solving just a basic equation. For number 2, we start off that way. I see that there's distribution going on, so I'm going to get rid of all of that. And then I start combining like terms. And at this point, I stopped. Why did I stop? The reason I stopped was because this first piece looks exactly like that back piece, which is telling me something. It's telling me that these 2 things are identical. I mean, clearly we could see that. If they are identical, that means that how many solutions would I have? I would have infinite solutions. If I have infinite solutions, the way you represent infinite solutions using set notation, what can n be? N can be any number, which means that using set notation, I would put all real numbers, my double R. So that is my answer. As soon as I see that I have identical expressions, one in the front and one in the back, I could stop. I could identify they're identical. I could say they have infinite solutions, but the answer I'm looking for, because they said set notation, is the double R inside curly brace. Let's go on to page 2. All right, so in page 2, we start off with some sort of function notation. So it's the same type of problem that we had, only that this time we have our funky f of x. So I'm going to start off solving this like I would anything else. I would be combining like terms. Okay, so I start off by combining my like terms on the left side. This is where I end up. At this point, I'm going to isolate f of x. So I get 13/3 f of x is equal to 7. How did I get 7? I subtracted 14 from both sides. So I sometimes do not show all my work because at this level, you should all know the process of solving an equation. So now I'm going to cross multiply. You end up at So your final answer should be 21/13. So let's try number 4. For number 4, I'm going to apply distribution first, then start combining like terms, then start moving things around, and let's see where that ends up. Okay, so I did distribution. I combined my 2 minus 45 to give me a negative 43 plus 3p of x is equal to 3p of x. So I am going to move those p of x together. And this is where I end up. I end up at negative 43 is equal to 0. The p of x canceled out on both sides. Is this statement true? Is negative 43 equal to 0? Is that even possible? No. So we have a false statement. If I have a false statement, that tells me that my problem or my solution is known as inconsistent. If it's inconsistent, that means that we cannot solve this problem. If I cannot solve this problem because I tried, what is the solution? The solution is no solution. It's the empty set. So how do you represent the empty set? Exactly like I wrote it there. This is known as the empty set. Nothing is in there if I'm talking about set notation. So let's go on to our next piece. Okay, so let's look at our next thinking question. We have, how do we solve equations using the calculator? So we're going to solve an equation using our TI calculators, our graphing calculators. One of the easiest ways to solve an equation on the calculator is by graphing. Note, this is not the only way to solve an equation on the calculator. So if you have learned a different method and you know how to apply it, you use it. Steps. What you're going to do using my graphing method is you're going to input the expressions into y equals. Then you're going to go to zoom 0. This is going to help the graph fit on your calculator. We might need to adjust that just slightly sometimes. The third step is you're going to press second calc, because we're going to want to calculate the answer, and you're going to press intersect, which is number 5, enter, enter, enter 3 times. The answer obviously is the value of x. So the x equals is what you're going to be looking for. If you have a decimal, because sometimes you will have decimal values, you do not want that answer to be on your paper because I will not give full credit. I want you to give me the fraction form. So to do that, you're going to go back to the main screen. How do you do that? You pressed second mode, and then there you're going to press second answer enter to get your answer back. So you're going to end up getting x equals, again, same decimal value, but to change now that decimal to a fraction, you're going to do math enter enter. And we all know how to do that. So let's look at the next example applying this calculator method. Okay, so let's try example number 2. And for example number 2, we're using our calculator, and I'm highlighting the front of the equal sign, which is my first expression, and the back of the equal sign, which is my second expressions. In algebra 1, we learned that an equation is formed by two expressions being set equal to each other. So I'm going to bring out my calculator, and I'm going to do the steps with you guys. So you turn on your calculator, you're going to go to y equals, and you're going to input the first expression, which is the blue highlighted piece. Instead of m, I'm going to use x. So I'm going to do that now. In the y2, you're going to input the green highlighted one, which is my second expression. And notice I did not do any distribution or anything. I left it exactly as it is because I'm using my calculator now. The next thing that we have to do is press zoom 0. That lets the calculator graph it for me. A perfect fit. Sometimes what you will need to do is press zoom 6, zoom standard, so you could bring it back to the regular graph. And you see how I only see one line. So zoom 0 will show the graphs a little bit better. Now that I have the graph there, I'm just going to think about my solution. I see two lines that are parallel to me. If I have two lines that are parallel, that means that there is no solution. There's no point of intersection. So I can gather that piece of information just by looking at the graph itself. So this is the empty set. We have parallel lines. For number 2, let's try it again. So I have, again, the front piece, the back piece. Anytime you have fractions in your calculators, you should be putting extra parentheses. That's just something that we have done since Algebra 1. So I'm going to go back to y equals, and I'm going to input both equations exactly as they are. All right, so I've input both equations. Again, notice my parentheses around my fractions. And now I'm going to press zoom 0. So here I clearly see a point of intersection. If you don't right away, press zoom 6 and then zoom 0 again. Since I see it, I'm not going to do that. So since I have a point of intersection, let me calculate that point. I'm going to do that by pressing second calc or second trace. Calc is right here. I want 5, the intersection piece. And at that point, I'm pressing enter, enter, enter 3 times. It gives me my answer. It's blinking here. My x equals is that decimal value. Do not give me decimal values. What I want is fraction form. Always. I want the most exact answer. So how do you get that answer? You're going to go back to the main screen by pressing second mode. That brings me back here. Then you're going to press second answer, which is the negative, enter, and it's going to give back the same exact x value that you just got from the graph. How do you change a decimal to a fraction? Math, enter, enter. So my answer to number 2, 125 over 29. Okay, let's try number 3. So for number 3, we have our front piece and we have our back piece. I have fractions, so I'm going to put extra parentheses around them. And I'm going to input this into y equals. So I'm going to do that and you guys try it too. All right, so I've input both expressions in there again. Notice my parentheses around those fractions. I'm going to press zoom 0. Okay, so in this case, I saw a line, blue line, and then the red line go right above it. So without doing any calculations, I should be thinking that these are the same lines. If I have 2 lines that are on top of each other, that means they're identical. That means that there's infinite possible solutions. The set of reals. So let's try one more. Let me move my calculator here. And for this specific one, instead of f of x, I am going to be dealing with x. I will need extra parentheses around every fraction. So I suggest you guys do this and let's see if we end up at the same answer. All right, so here are my 2 inputs. That's how I've input it. And now I'm going to press zoom 0. I have a point of intersection, means I could press the second calc, 5, my intersect, enter 3 times. Gives me my answer as a decimal, and I don't want those decimals. So second quit, second negative, which is answer, enter, and I'm math entering this. So I get a value of negative 71 over 40. Now for these, if you write x equals or f of x equals as your answer, m equals, I will take it because I didn't specify I wanted it in set notation. But since we have been doing set notation in example 1, I decided to stay with set notation. So keep learning, keep growing, and I'll see you in our next video.